Hello everyone. Now that we have some tools at our hand, that is the distance functions and the linkage methods, let us go to the actual cluster analysis procedure. So let me list down the steps and then we will try with one example. Okay. So what you do is, in the first step, you suppose you have n objects. So let n objects be there in our data set. Then first thing you do is, we will talk about hierarchical clustering first. In hierarchical, we will discuss only agglomerative in theory. We won't go for divisive, it's slightly advanced. Okay. So, compute distances between every pair of objects. Okay. So, compute distances between every pair of objects. So you get what is called as a distance matrix. Okay. So you get an n cross n distance matrix. How does it look like? Let me show you. So you have kind of O1, O2, On on this row and O1, O2, On on this row. So you have n cross n matrix. Of course, along the diagonals you have zeros because it is distance of an object from itself, and the matrix is symmetric because here you will have distance between O1, O2 and here you will have distance between O2, O1. So these two things are same. So the matrix is symmetric and the off diagonal entries are greater than or equal to 0. They can't be negative because it's a distance. Okay, diagonals are 0, off diagonal entries are greater than or equal to 0. So you prepare such distance matrix. Then in this distance matrix, you try to locate the value which is smallest, of course, other than 0. So try to locate the smallest non-diagonal entry. Diagonal entries are anyway distances between objects. So smallest non-diagonal entry. Suppose smallest non-diagonal entry is somewhere here. So O2 and let us say O5. Then it means that among these n objects, O2 and O5 are closest to each other. So join the corresponding objects to form one cluster. Join the corresponding objects to form one cluster. So now you have O2, O5 in one cluster and everything else in their own cluster. So you will have n minus 1 cluster. So O2, O5 is here and everything else is separate. So O1 is there, O3 is there, O4 is there, etc. Okay. Then now that you have n minus 1 objects instead of n objects, you create a new distance matrix. So create a new n minus 1 cross n minus 1 distance matrix using the linkage method on these n minus 1 objects. Okay. So what do you get? You get n minus 1 cross n minus 1 distance matrix. So you have group 1 and then group 2, group 3 are actually singles, but you can call them group 1, group 3, group n minus 1. Similarly, you have group 1, group 2, group n minus 1 and you get a new distance matrix. Diagonals are 0 and everything else is either 0 or positive. Okay. Remember, as soon as you get this new distance matrix, you have to kind of throw away the old matrix. So whatever you do further would depend on this matrix. So in this matrix, you again locate the smallest entry and you go on repeating this process till you finally have every object in one place. Okay, so again locate the smallest entry, join the objects, etc, etc. So repeat steps 2 and 3 till everything is in one place. Okay, let us solve this via example so it would be even further easier to understand. Okay, see, let me stick to the example of fruits, and we'll have multiple variables and we'll define binary distance. So let me take mango, grape, watermelon, orange, and maybe chiku. And maybe guava. Okay, and the factors that we are considering are, say, size, how many seeds they have, and let us say taste. Okay, and maybe color. So mango size is medium, grape is small, watermelon is large, orange is medium, guava is medium. Number of seeds in mango is 1, grape let us assume seedless, so 0, watermelon many, so many let me denote by 2, orange also many, guava also many. Taste, mango is supposed to be sweet, grapes let us say sour, watermelon sweet, orange will say sour, and guava also let us say sweet. Okay, let's say it's fully ripe. Color, we are talking of external color, so yellow, let us say green, watermelon also green, orange is orange, and guava is yellow, sorry, green. Okay, now we are not going to treat some colors as similar, we are going to treat every color as separate. If you want, colors also to be quantifiable, like yellow is closer to orange, then you will have to use their actual maybe RGB ingredients or CMYK ingredients to see the closeness, but we are not going to go there. And we would use the binary sort of distance. So let us first prepare the distance matrix. So now distance between mango and grape. So how many parameters are they, on how many variables do they match? No, 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 no. So they don't match anywhere. So the distance is complete 4. Number of mismatches is 4. So let me prepare first distance matrix. Mango, grape, watermelon, orange, guava. Mango, grape, watermelon, orange, guava. So this is of course 0, 0, 0, 0, 0. Mango to grape we just saw distance is 4. Mango to watermelon. Sweet and sweet. So this is matching. Everything else is different. So 3 mismatches. So distance is 3. Mango to orange. Medium, medium is matching. Everything else is different. So mango to orange also I would say distance is 3. Mango to guava. Okay, grape and guava. I need to write GR and GU. Okay. Yeah, medium, medium is matching and sweet, sweet is matching. So 2 things are matching. So number of mismatches is also 2. Then grape to guava. So grape to guava, grape to grape, we have to compute all. This I directly have. Grape to watermelon. So this is not matching, this is not matching, this is not matching, but the color is matching. So 3 are not matching. Then grape to orange. No, no, sour, sour is matching. So again 3. Then grape to guava. So small, medium, 0, 2, sour, sweet, green, green. Only green, green is matching. So 3. Then watermelon to orange. Watermelon to orange, 1, this is matching, and so only seeds is matching. So 3 are mismatching. Watermelon to guava. Watermelon to guava, seeds are matching. Okay. Taste is matching and the color is also matching. So let us say 3. Now orange to guava. Medium 2. So 2 things are matching, 2 are not matching. So 2. Okay. So now we have this distance matrix. We have to locate smallest non-diagonal entry in this distance matrix. We actually have 2 at 2 different places, so we can randomly select one of them. So let me select this. So mango and guava. So we will say that we will join mango and guava at the distance of 2 units. Okay. Then we will construct the groups. So my group 1 is now mango and guava. Group 2 is grape. Group 3 is watermelon. And group 4 is orange. So I have to now construct a distance matrix based on these 4. So I have group 1, group 2, group 3, group 4, group 1, group 2, group 3 and group 4. Let us use average linkage method here. As a homework, you can try with other linkage methods. So I have to compute distance of first group from each group. So G1, G2. So distance of mango guava from grapes. So it would be average of distance between mango grape and guava grape. So distance between mango grape and guava grape. So mango and grape, the distance is 4. Guava and grape, the distance is 3. So average distance would be 3.5. So this is 3.5. Okay. Similarly, now first group and third group. Third group is watermelon. So mango watermelon distance is 3. And then guava watermelon also distance is 3. So average is 3. Then mango orange distance is 3. And guava orange distance is 2. So average is 2.5. Okay. Rest of the entries we can copy from the earlier thing. G2, G3 is grape and watermelon. So grape and watermelon was 3. So let me keep it as it is. Then G2, G4 is grape and orange. So grape and orange was also 3. So let me keep it as it is. Then G3, G4 is watermelon and orange. Watermelon and orange is again 3. So let me keep it as it is. Okay. So now I have new distance matrix, and remember, as soon as I get new distance matrix, we have to forget about the old distance matrix. Now in this new distance matrix, I have to locate the smallest entry. So the smallest entry here is 2.5. So at the next step, I join G1 with G4. So G1 is already mango and guava. And what is G4? G4 is orange. So let us put these 3 together. So my new revised G1 becomes mango, guava, orange. G2 is still as it is, that is grapes. And G3 is still as it is, that is watermelon. Okay. Now let us prepare a new distance matrix based on these 3 groups. Now this step is crucial. Okay, this is slightly unexpected thing. So G1, G2, G3, G1, G2, G3. Of course, diagonal entries are 0. Now G1, G2 means I want distance of this big group now with grapes. Okay, so I want distance of M, mango, guava, orange, this group with grape. Now remember, for us, mango and guava were already a group in the earlier thing. So we would treat them as group. So I would write this as distance between mango guava to grape plus distance between orange to grape by 2. We won't take mango grape plus guava grape plus orange grape by 3. This is very important because we are doing hierarchical clustering. As soon as we had D2, D1 is gone from our memory. So while constructing D3, we are going to use only D2. We are not going to use D1. Okay. So distance between mango, guava and grape, what was that distance? Let us see. Mango, guava and grape. See. So it is G1, G2. So that is 3.5. And then orange to grape was orange was G4. So orange to grape is 3. So it would be average of 3.5 and 3. Okay. So it is 3.5 plus 3 by 2. So basically this is 3.25. Okay. Similarly, we want distance of this group with watermelon, right? G3 is watermelon. So we want distance of mango, guava, orange group with watermelon. We will write it as distance between mango, guava and watermelon plus distance between orange and watermelon by 2. Okay. So mango, guava and watermelon would become, mango, guava was G1 and watermelon was G3. So G1, G3 was 3 units, and then grape to watermelon, so G2, G3 was also 3 units. So this would be 3 plus 3 by 2, so basically 3. Okay. And G2, G3 is distance between grape and watermelon. So that is as it is, we have to copy. So grape and watermelon was G2, G3 here also. So it is 3. So now we have this new distance matrix. We have to locate smallest entry here. It can either be this or this. So let me now choose this. So G2, G3. So we would put grape and watermelon together as a second group. So now my revised groups are first group is as it is. So first group is still mango, guava, orange, and now second group is grape and watermelon. So now I need the new distance matrix G1, G2, G1, G2. So the distance between these two, so this would be written as mango, guava, orange were anyway together, so distance between mango, guava, orange group and grape plus distance between mango, guava, orange group and watermelon divided by 2. So mango, guava, orange, let me go up and check. Mango, guava, orange with grape, so this is 3.25, and mango, guava, orange with watermelon is 3. So it is 3.25 plus 3 by 2. So it is 3.25 plus 3 by 2. So this is 3.125. Okay. So 3.125. Now at this stage, of course, we have only two groups, so we are putting them together. So my final group consists of all the fruits: mango, guava, orange, watermelon, grape. Okay, our job is not yet complete, because as we said, ideally we have to stop somewhere in between to get in some sense meaningful groups. So to do that, we will draw the dendrogram. Okay, so what we have on the x-axis are the fruits, and means the objects, and on y-axis we can have either distance or similarity. So here we would we'll put distance on y-axis. On x-axis we should arrange things in such a way that those which join first should be close to each other. So the very first group that was formed was mango and grape, then mango and guava, then orange got joined to it, right? So let me write that way. So first we have mango, then guava, then orange, and then watermelon and grape joined to them. So watermelon, grape. Okay. Now at what distances did they get joined? So mango and guava got joined at the distance of 2. Okay. So let me put numbers on the y-axis. So suppose you have 1, 2, 3, 4. So mango and guava got joined at the distance of 2. So at the height 2, I draw a horizontal line and then I connect two ends of that line to these two. Okay. Then after that, orange joined them at the distance of 2.5. So 2.5. So here orange joined them. Okay. Then watermelon and grape got joined at the distance of 3. Okay, at the distance of 3. And finally these two groups got joined at the distance of 3.125. Okay. So this is the branch type or diagrammatic representation of the entire clustering procedure, and as I said, this is known as dendrogram. When you type this in Word, it would give spelling error because it doesn't know this word, but this is the correct spelling. Dendros means branches, so it is dendrogram, branch type representation, and these are of course supposed to be straight line. Okay, even though they are not looking straight here, they are supposed to be straight lines. Now, after drawing this dendrogram, you decide what distance level is acceptable to you. Suppose for you only this much distance within group is acceptable. Then you say, okay, mango and guava, let them be in one group, but everything else is separate. Okay, so this is 1, 2, 3, 4. That is, we'll get 4 groups. Okay, so this is how hierarchical clustering works. Let me stop here. We'll discuss k-means clustering in the next lecture. Thank you.